Here's another system of linear equations. We're going to solve by substitution. Look, I have 2x minus 3y equals 12, that's equation 1, and x minus 1.5y is 6, that's equation 2. So I see that equation 2 can be easily solved for x. If I solve equation 2 for x, we get x equals 6 plus 1.5y. And then we want to substitute this in for x into equation 1. So we substitute this in. So equation 1, if we bring equation 1 back down here, we get 2 times this here, 6 plus 1.5y, minus 3y equals 12. And then we're going to expand this. So if we expand it, we get 2 times 6 is 12. 2 times 1.5 is 3y, minus 3y equals 12. Then we group our terms together. If we get 3y minus 3y, that's 0. And we subtract 12 from both sides, you get 0 equals 0. Well, that's interesting. 0 is always equal to 0, that's for sure. 0 is 0. So what does this mean? Well, when you get a solution that's true always, like this, it means that there are infinitely many solutions to this system of equations. And if we actually look at this more closely, if we look at these two equations, we could see that the second equation is actually just half of the first equation. They're actually the same equation. If I divide everything on top by 2, we get the second equation. And so in this situation where we get 0 equals 0, it means there's an infinite number of solutions. So we will say an infinite number of solutions. Infinite solutions. And why? Because actually they're the same line. If we solved each one of these for y, we would see that. And let's take that. Let's look at that right now. We see that both of these equations are actually the same thing. And that's why the solution to this system is an infinite number of solutions to this system. Here's another system we're going to solve using substitution. The first equation is negative 4x plus 2y equals negative 16. And the second equation is 2x minus y equals 12. So we want to solve this and find the solution if there is one. So I can see like the bottom one seems like it's easier to solve this for y. So if we solve this for y, and if I move the y to the right side and subtract the 12, what we'll end up with is y equals 2x minus 12. So make sure you can follow what I just did. I moved this 12 over here, subtracted and moved this y over here. And then I rewrote it in terms of y. So y equals 2x minus 12. So now we can substitute that in to the first equation. And if we substitute that in, we get negative 4x plus 2 times 2x minus 12, which is what we're substituting for y, equals negative 16. And then we expand this to get negative 4x plus 2 times 2 is 4, so that's 4 plus 4x, plus 2 times negative 12 is negative 24, equals negative 16. And then we can combine the x's and move over the 24, so what we end up with is negative 4x plus 4x, that gives me 0. And then if I add 24 to both sides, we get negative 16 plus 24, we get 8. So, is 0 equal to 8? No. So this tells me something is wrong. Now I should go through and check my calculations to make sure I did it properly. But if I end up with a situation where we have a false statement, that means this system actually has no solution. So there's no solution to the system. And what that means is actually we're talking about two lines that must be parallel. Because if there's no solution, that means they never intersect. That means they must be parallel lines. They're not the same line because that would be an infinite number of solutions like we saw previously. These are two different lines, but they're also parallel. Now, in order to see that graphically, we would solve each one of these for y and graph them. So let's do that. So we want to look at each of this system of equations. Negative 4x plus 2y equals negative 16, and 2x minus y equals 12. First of all, we need to solve each for y. Negative 4x plus 2y equals negative 16 becomes y equals 2x minus 8. So under our y equals, we put in y equals 2x minus 8. The second equation, 2x minus y equals 12, if we solve that for y, we get y equals 2x minus 12. So the second equation is 2x minus 12. Y equals 2x minus 12. Under our y equals editor. And we want to show that these are actually lines, there's no solution, that these lines actually are parallel lines. We can click on zoom, and then 6, which is zoom fit, and we see the two lines run parallel to each other. And if I were to zoom into that area, let's hit zoom, and then in, and scroll to between the two lines so we could see what's happening there. Hit enter again. There's one line, there's the other line. And at a close-up we can see that those are actually parallel lines. And the reason is that they have the same slope. Going back to our y equals, we could see the slope of y1 is 2 and the slope of y2 is 2, but they have different y-intercepts. So if they have the same slope, they're actually parallel lines. So we've actually looked at three types of solutions to linear equations. The first type is when we find an actual solution that's a point, where there's one solution where the lines intersect at one point, and we call that system actually the independent system. Then there's the situation where you actually have the same line. The two linear equations are actually representing the same line, and you have an infinite number of solutions. We call that a dependent system. And then the final system is where you have no solution, and that's when you have two parallel lines. Well, they will never intersect, so there's going to be no solution, and we call that the inconsistent system. Now we're going to look at another way of solving linear equations. We've looked at substitution. Let's look at another method called the addition or elimination method.